Okay, so I want to talk about containers. Containers is a hot topic these days, right? Everyone is talking about containers, but when I visit customers and partners that I work with, nobody is really doing containers. And so, what is all the fuss about the containers, right? Nobody is really doing containers in production anyway. So, what's all the fuss about these containers? First of all, I wanna explain this by this example, right? Everyone knows this statement. It works on my machine. You develop some awesome application and you deploy it in a test environment. And when you get that working, it's being released by some other person on acceptance, and it doesn't work. And it's always the other person's fault. It's hard to track what goes wrong, and that has everything to do with the environments having different configurations, different resources, maybe different sizes of virtual machines, different components, maybe a load balancer in front of it. So what it comes down to is that every environment is different, right? And if you deploy your application and your application travels from one environment to another environment, all those differences can cause your application to fail. If we package that application in a container, then the container contains also the configuration for the application. It contains the middleware software that you require, or the base image, and that will never change, no matter what environment it goes to, as long as there is in this case, a Docker agent that's running your container. Your application will run no matter what configuration the underlying infrastructure has. Another advantage of containers is this. So when we look at traditional computing, right, and we look at the physical server, we see an operating system with a hypervisor. It doesn't matter what type, and we chop up the total amount of resources that a server has into sections, and we create virtual machines. And those virtual machines require to run a full operating system as well, which takes up a lot of memory and CPU time as well. And on top of that, we are deploying our razor fast Node.js application that can really optimize the use of resources, right? You can see the contradiction there. And if that isn't bad enough, we also have the tendency to over-provision our virtual machines, because who knows what our application is going to do when all of a sudden all those users hit it, right? So we tend to be very conservative, and we want to assign more memory to it, because we don't really know what's going to happen to our application. So what would be a better solution is that we have one VM, or even drop out the whole virtualization layer, and we have one operating system, and we deploy multiple applications on that operating system. Right now we are more efficient with the resources we have on that physical server. The problem here is that if one application goes rogue and takes up a lot of resources, a lot of memory, a lot of CPU time, then it affects all your other applications on the server. Right? So if we contain the application in a container, and an application goes rogue, then it will be contained in the container. How many times can you say contain? But it won't affect your other applications, right? So that's a good thing. So let me just give you a demo of containers, right? And I'm going to create a small application, and I'm going to show you how our tooling can work with that, and how we integrate the working with containers into your workflows. So I'm just guessing that this will be the most familiar environment for you guys, a bash, a shell, whether it's Mac OS or Linux. If I guess wrong, please forgive me, but I'm going to show you this in bash. You can also do this in PowerShell if you like. So we really invested in bringing open source technology to our platform everywhere, right? So we have now a Linux subsystem in Windows 10. All of our tooling that comes out is available on Windows, on Linux, and on the Mac. And I'm going to show you how that integrates. So let me quickly go to my folder here. I'm going to create a simple Express application. I'm not going to do anything fancy. I'm not going to teach you how to do advanced stuff in Node.js. I think you guys can teach me on that, right? But I'm going to create a simple Node.js application. All right. So as you can see, I can use all the tools that I'm accustomed to. I can use npm, I can use Git, I can use apt-get. This is an Ubuntu distribution. But in the near future, you can also use Yum or anything else, as we provide a selectable subsystem. So you can choose whether you want to run CentOS or Ubuntu or another distribution, which I forgot. Anyway, this is almost finished. This is all familiar to you guys, right? But I just want to show you that this is just from a clean slate. There we are. And I can do, of course, an npm start, and this application will run, right? I don't have to show this. Localhost 3000. You've probably all seen this template. So now I want to change this application. All right, I want to make it a little bit more interesting. So for that, I'm going to open Visual Studio Code. Visual Studio Code is one of those tools I talked about that is available on the Mac, on Linux, and on Windows. And Visual Studio Code is a lightweight editor based on the Atom engine Chromium. So from the Linux subsystem, I can just say code dot. And this is one of the improvements with the latest creators update. I can now reference applications that run on Windows from Linux, which is a great improvement. And here you can see all the assets that are in my application. So I can quickly change this. I can say let's make this a little bit bigger, and let's inject a name. It says this application is running on and a host name. Right, and we're going to need that later. Now, of course, I need to fill that up. So I'm going to say welcome Node.js Munich. Name Christoph. Did I spell that right? I think I did. Yeah, I did. Okay. And host, I'm going to say os.hostname. And we're going to use this throughout the rest of the demo. For os equals require os. That's the most typing I'm going to do from now. Okay. So we changed this application, and we're going to run this in a. Let's first look if I didn't make a typo. Right, I've fallen for that one a couple of times. So I can open in this tool. I can open up the Bash shell as well, and from here I can do an npm start, And of course, it'll be exactly the same. We should have that open. Oh. There we go. Right, so my changes worked. I can also debug it, just like you would in Atom. You can just debug it, and there you go. So my application works, and now I want to show you how we can package this in a Docker container. Is anyone here using Docker at the moment for production? For production, yeah. Okay. So not too many. So my observation in the field is actually correct. A lot of people know Docker a little bit. They play with it, but in production they don't really have a feel how to apply it. And I hopefully after tonight you will have a better understanding of how you could use it and why. So for the people that don't know Docker, Docker requires us to put our application, our code, in an image. And that image is prepared, it's versioned, and we can upload that image to a registry, a container registry. It's actually a container image registry, but everyone calls it a container registry. And you have public registries, you have private registries, you can have hosted registries, you can host your own registries as well. So we need to do that, right? And in order to do that, we need to add a Docker file that describes what will be executed when we build an image, right? Now you can type that by hand if you like, but in Visual Studio Code, I can pull up a command palette by typing Ctrl-Shift-P, and then I can just say Docker, add Docker files to workspace. And then it asks me, what are you going to build? Right? I'm going to build a Node.js application, and I want to expose it on port 3000. And as you can see, I don't know if you all can see that. As you can see, the extension added a couple of files. The only one I'm currently interested in is the Docker file. The other files are there for more advanced stuff with Docker Enterprise. So if I open up that Docker file, it looks like this. So a Docker file typically starts with from, and you indicate the base node, right? And in this case, there's an image in a public registry called node, and it has a tag 6, so it will be node 6. And it is based on Alpine, and Alpine is a very small container distribution, right? So it's the smallest container distribution that's there right now, and you want your containers to be small because your containers need to be deployed really fast. After that, you can set environment variables, you can set a work dir inside the container, you can copy some files over, you can run npm install to pull in the node modules. You copy your code, of course, and then you expose port 3000, and the command that it will run when it starts up will be npm start, which is specified in the packages JSON. So now I want to build this container. First of all, I've added all of this. I want to commit this to Git, right? And to do that, I don't have to go to the command line. I can just go to the Git section in the tool, and I can say initialize repository. And now I can see all the changes in my workspace, and I can add them one by one, or I can add them all at a time. And I'm going to call this initial commit, like everyone else does in a demo. And there you have it, it's committed. So let me get the hash. Describe. There's the hash, and we're going to build this image the right way. So to build it, I can pull up the command palette again, type Docker, and as you might have guessed, there's a build image. Build image lets me select a Docker file, so we can create multiple Docker files if we like. And then it asks me what I want to call this image. So I'm going to call this pvendor / and then the name of the application. When I do this, this will reference my public Docker hub, so I can push it later on. And then, as a good practice, I use the commit hash as a tag. Right, that's my version. Now it's going to build that container, the image. So this step is going to take a little bit of time because now it is running the npm install. It'll drag in all the node modules and install them in the image. So a Docker image has its own layered file system, and it can use that to store the data. Okay, so now it's done. If I do Docker, I don't have to go there. I can just pull up the command palette again, and I can say Docker run. Right? And Docker run does underneath does a Docker images, which pulls up all the images that I created on my machine. Right? So the top one is the image I just created, and I can say Docker run just to test if my Docker container will work. Exciting. And if I go to the local host 3000 again, you can see it still works, right? I shut down the other one, and now the application is running on that weird looking hash. Now that weird looking hash is actually, if I do a docker ps, I will get information about my running Docker containers. That is actually the container ID. You see? The container ID will be the host name in the container. So let me quickly remove this before. So now we tested our container. Everything is wired up. The image works. Now I want to push it to my Docker registry. So I can say Docker push. And I can say select the image I want to push. And this will go out to Docker Hub, and I'll show you that in a sec. And it's pushing that image to Docker Hub. So let me try that again. Why is that? Sign in. Let me sign in again. Signed in. Oh, okay, I'm going to cheat. Sorry. I made some last minute changes to my configuration, so I can show you this in Bash here. But apparently the push, I forgot a specific configuration there. So I'm going to quickly change the PowerShell, and I'm going to try that again. Man. So it's not that. I want this to work. Just act as if you didn't see this. We can cut this out of the video, right? This is my local configuration issue. So there we have it. It is pushed. If I open up my Docker hub right now, and I refresh the page, then there's a Docker container, or an image. And as you can see, there's a tag, right? Okay, so that's the workflow that is normally done when working with Docker containers. Okay, let's move on with the presentation. So now we have a container. Now what? We have a container, but that's no guarantee that the container will always be up and running. You don't want one container. You want a microservices architecture or something like that. You want a SQL system or a NoSQL system or a queuing system. You want all sorts of things in there, right? And they need to be able to communicate with each other and find each other, and it needs to be highly available. So speaking about high availability, the problem with the picture I painted before is that even though we have container applications, the underlying layers can still fail. So the operating system, the hypervisor, virtual machines, they can all fail, right? So what you want to do is you want to deploy your application multiple times on multiple servers. And you want to spread out the risk, so to speak. But to do that, you need some sort of orchestration. You need some sort of brain to keep track where is what application deployed. How many instances are there? How many instances should there be? What is the state of the application? All those things. There needs to be something that can keep track of that. And we call that container orchestration. And there are several systems that do that, and Kubernetes is one of them. Right? And I'm going to talk about Kubernetes. So container orchestration in a nutshell, we want to be able to address our applications. So they need to have, if we have multiple applications, we need to have a single IP address we can talk to, right? And preferably, we want a name. We don't want IP addresses. So that's one thing. The other thing is, other services need to be able to discover the distributed services you already deployed. So that should be implemented as well. So they need to be able to call them by a name, no matter what IP address is behind it. And we want to be able to do that for multiple services, of course, and we want to be able to link them together. But we also want to be able to expose applications to the outside world. Up until now, it's all private IP addresses. This is not something that you can call from outside the cluster. So we'll need a way to expose our application to the outside world. And for that, we need a public IP address and preferably a URL, of course. And the container registration needs to be aware of where your services are running. So if one server fails, it needs to distribute the applications evenly over the remaining cluster until someone or something creates a new server and adds it to the cluster. So looking at the Kubernetes architecture, you can all see this? No? Let me zoom in a little bit. The Kubernetes architecture consists of two parts. One part is the brain, and one part is the worker part. Right? The part you're looking at here is the brain. The brain we can manage, so we can configure the brain, or we can call upon the brain and ask it stuff. So there's an API server that we can use to manage pods and services and controllers and such. And I'll get into them a little bit later. On the other side, there is the worker part, the worker part needs to be accessible from the internet as well, right? So there needs to be an internet gateway, or however you want to call it. And then a node has a couple of services, a kubelet and a proxy. The kubelet will monitor the state of the containers, and the proxy will know exactly the IP addresses of the pods that are deployed on that node. A node is a server. Docker needs to be deployed on the node. Kubernetes talks of pods. So I just shown you one container, but a pod can contain multiple containers. Usually we will see a pod with a single container, but there are valid scenarios where you want containers to start together, or to share the same IP address, or to share the same file system, right? In that case, you wanna host multiple containers in a single pod. So a pod can be thought of as an IP address, basically. So every pod has a unique IP address in the cluster, and you can specify the individual containers within a pod through port mapping. So if we look at this says nothing about the implementation. Right? Kubernetes is one thing, so the kubelet and the proxy, and there's an API server there. That's one thing, that's typically Kubernetes. But you'll have to have a distributed distributed storage mechanism like etcd or Zookeeper or Consul to maintain the state of that master, that brain of Kubernetes. So that needs to be configured. Docker needs to be configured. The network needs to be configured. Access from the internet needs to be configured, and that's really difficult. Right? Installing and configuring and maintaining Kubernetes is extremely difficult to do right, and you have a lot of choices on what components to use as well. So let me show you what Azure Container Service can bring to that. So if you go to portal.azure.com, then you come into the Azure portal. The Azure portal consists of multiple dashboards. I mean, you can configure any amount of dashboards that you want for specific scenarios, and get the right information that you want. But you can also create all sorts of resources. We call these resources. Right? And those are services that we offer that can help your application to do stuff. So database as a service is one of them. Machine learning as a service is one of them. We have cognitive services that can help you make your intelligent predictions in your application and stuff. So to create an Azure Container Service, you just type in container service. Is it there? Container. There. And hit create. Then you can select the type of orchestrator. Can everyone see this? Yeah. You can select DCOS, Kubernetes, or Swarm. All right, these are the flavors that we see in the market today, and these are the flavors that we offer currently. So in this case, we're going to select Kubernetes. We're placing the resources in a resource group, so we can manage them together. We can manage access to all those resources together. And after this demo, I can delete it altogether, right? That's easy as well. So I'm going to create a new one. No, Munich. And you can select a location. I'm going to select my own country, West Europe, but you can select any location that you like. You hit OK. Then we come to the master configuration. The master configuration has an endpoint for the API server, so that's a URL that needs to be unique. right? So we allow you to provide a DNS prefix that will make the rest unique, right? So I can type something in there, and it'll do a check whether it will be unique. So it'll concatenate this with the actual value that it will be, and it does a DNS check as well. I need to add a username. I need to add the public key that I generated for authentication. So I'm just going to add this here so you can see what we have to do to create it. I'm not actually going to create it. Then there's a service principal. Service principal allows services to communicate in a secure way with each other, right? So that the container service I'm creating here cannot communicate with the container service that I created earlier because it has a different service principal. I'm just going to fill in a dummy value here. If you go to my GitHub, I've created the scripts to create this from scratch, and there, with the scripts, the service principal will be generated automatically. So you will not have to enter all this information. The master count as default is 1. It's not something we recommend for production, obviously, due to the chorus-based state of etcd. It is required to have 3 or 5 or 7. We never encountered 7, so it is 3 or 5 right now. And you can just select that and hit OK. Then we need to configure how many worker nodes do we need, and we call them agents. Right, so let's say 3, and we can decide how big the virtual machine should be that will have that capability, right? And we will do a recommendation here, but you can select a lot of virtual machines sizes that you really want. And we're actually working in a community very closely with the community to get Kubernetes also on Windows, and we started a preview for the Kubernetes cluster on Windows as well. I'm going to show this on Linux. So after filling out these couple of this short information, you will get an overview. If you hit OK, this will rattle for like 10 to 15 minutes, and then it will create what I'm going to show you right now. So this is the resource group that I created earlier, and let me just. Oops. So it created some storage accounts to host hard disks and stuff. It created virtual machines for the agents. It created an availability set for those agents, agent machines. The availability set means that every virtual machine that's in that availability set takes into account that if one virtual machine fails, not all your applications are on that one virtual machine. Right, so that's and also when we upgrade the base OS or the base image or something like that, we will not take down all the machines in an availability set at once. So your application will always be available in those circumstances. It creates some network interface cards. It created the master nodes, right, with the same settings. It created a virtual machine, a virtual network, a public IP address. And a load balancer for the master. And it created a Kubernetes cluster object. And if I click on the Kubernetes cluster object, we get some degree of manageability here, but you really don't need to use this a lot other than scaling out or scaling in your cluster. Okay. So. Quickly going back. So this is what we create. We automatically create the load balancers, and everything. Now we have this infrastructure. Now you need a way to connect to it and to work with it, right? And you need to set up your client side as well. On my GitHub, I included 2 lines of Bash script that will install the client interface, the command line interface for Kubernetes kubectl, and also gets the credentials for that. So if you go to my GitHub, you can see how that works. After you set that up, you can work with Visual Studio Code to manage your applications, your deployments, and infrastructure there. And I'm going to show you that right now. So, coming back to our application, we had the container. The container was pushed. I can now do a kubectl get nodes, for instance. I can get information about my cluster. So I will get the same information that I got from the portal. I can do a kubectl deployments. Get deployments. And I hope you can see the logic in this. This is really intuitive. This is really intuitive. So no resources found. There's no deployments, right? No rabbit up my sleeve. So what I want to do now is I want to deploy this. So I can pull up the command palette again, and I can say Kubernetes, and I can say run. Oops. Oh, yeah. Doesn't matter. It's very forgiving for typos. Or isn't it? There we go. So it built the image, build a new image. This automatically creates a new tag and gets the tag, and it'll push it. Now it does work, the push. And it'll deploy it. And I tried it twice because I was impatient, so the second one didn't work. Okay, so as you can see, it builds my Docker image. It pushes the Docker image to Docker Hub or whatever registry I want to target, and it deploys it to Kubernetes. So now, if I just clear my screen here and I do a kubectl get deployments, I will get a deployment. Now this doesn't say very much. I can do a describe and I will get a long list of variables, but I can do something very more valuable than this. I can say Kubernetes load, and then I have to say what resource do I want to load, and I can say deployments / simple express. You see how intuitive this is? Now it goes out and it will get the JSON of that specific deployment. And if I like, I can store this JSON file. I can say save, and it'll be put in my workspace. Right? I can store this in Git. And I can also look at this through the Kubernetes portal. So I can open up a proxy to Kubernetes and go to this IP address. And I will get the Kubernetes portal here. And I can see my deployment, and I can see there's one pod currently running. I can see how many memory it takes. And so on. So now I want to be able to scale this application as well. So let me quickly go back to the resource that I just created and say, well, I want to change it so I need to remove the revision version. And I want to say, well, let's scale this to 5 replicas. Save it. And then I can say Kubernetes apply. And because this file is in the context, it'll know what to do. And all the errors that you see here, I mean, this is all open source. So I invite you to get these errors out. I have a link to the actual repository here. So it's actually this extension. And if you like, you can also contribute to VS Code or any other extension as well. So deployment configured, right? It did work. So let's go back to the portal here and show you that it did work. Just refresh it a little. There you go. We have 5 pods running currently. Now we have 5 pods, but I have no way to target or to reference that application. I cannot test that application and see if it's working. So I need to expose this set of pods to the outside world. Right? Can be to the outside world, can be just within the cluster, but I'm going to expose it to the outside world. And this is also very, so I'm going to type in Kubernetes expose, and then I need to let the API server know what I want to expose. It's the deployments / simple express, and I want to specify a target port 80. I want my website just to be available on port 80, and I need to specify a target port, and that's the port that my application is actually listening on. So that was 3000. And this will be enough for an internal service, right? And if I want to make this an external service, I can say type equals load balancer. Did I make? So in the command prompt, you don't have to type Kubernetes. It's just kubectl. There we go. And the service is exposed. Let me just blow this up a little bit. The service is exposed. So there should be a service now. So if I say kubectl get svc, and svc, and I'll just add a wait. Then you can see that my simple express service is created. Any other service that is running in the cluster can now reference simple express. And simple express will resolve into that 10.0.181.190 IP address. Right? So that's internally. And as you can see, the external IP is still pending. And that is because, and this initial demo is takes a little bit longer because it's also creating a load balancer actually to enter the cluster on the worker side. And then it's going to add the inbound net rules to point to this specific service. Let me just quickly do that. So if I go to the Azure portal, you can see those resources being created. Let's just refresh this. And you can see there's an additional load balancer here. And it is configuring that load balancer right now. It is configuring a public IP address as well. It will enable me later on to reference that and to get my application running. No, not yet. So this is taking a little bit of time, and but I hope you understand that this is the way how you can work and how the flow is integrated in our tooling as well. Let me just finish with 2 more slides, and then we'll pull up the service again. So in my GitHub repo, like I said, we have an Azure command line interface that I'm using in the scripts to recreate this demo. You can just execute that, fill out some environment variables, and it'll just work. We will provide you in this session with Azure passes. Azure passes. So if you like, you can come up to me or to Susanna. And an Azure pass gives you $100 of Azure credit per month for 3 months. So in total, it's $300. And you can play with the stuff that I just shown you, and you can try this out. Visual Studio Code is free. All the tooling I've shown you is free. So oh yeah, and please don't forget to fill out our post-event evaluation. That really helps us improve our sessions and keep it sharp. Yes. Okay. Let me quickly go back to service. There it is. So I want to leave you with our application running in Azure, in Azure Container Service on Kubernetes, and we just deployed it. These are five pods, and if I refresh it, from some browsers, it refreshes. There you go. So this is another one. Let me refresh it again. So you can see it change, right? So it is hitting the individual pods. Okay, with that, I would like to thank you for your attention, and I would like to give the floor to the next speaker.